Let's look at SolidWorks Electrical and SolidWorks Electrical 3D. Our job today is to route a control panel very similar to this one. This will be done using the 2D schematics defined in SolidWorks Electrical and the 3D layout defined in SolidWorks Electrical 3D. And this will provide us cable and wire lamps. So we can see that a SolidWorks Electrical project can contain multiple document types. Some of them can be PDFs to provide information about the devices that we're using in our project. We see here a location, so we can define our assemblies with locations. So electrical components will be located in those specific locations, and SolidWorks Electrical will verify if all those connections are logical between the locations. So our job today is to add a motor to our assembly, and this motor will be connected to X1, and this will provide a link to our contact and breaker, and we also have to provide power to our PLC using the transformer T1. Okay, so let's open our subassembly to add the motor. So we can see that we already have some components added to our control panel, but we don't have the motor inserted yet. So we're going to use SolidWorks to simply add this to our assembly. And if we look at our electrical components, we see that we have a bunch of components already inserted, and the last motor inserted was M4. Okay, so let's launch SolidWorks Electrical. And we can see here that it's indicating that the project is already being used by a user. But it doesn't matter because SolidWorks Electrical enables multi-user environment, so multiple people can open the projects at the same time. So let's open the diagram, and we can see that we have the markup. So let's remove the markup here and add our motor. So we're going to insert the symbol for our motor. As you can see here, the system is always providing me with the last symbol that I used, but I can also always use the library to select the proper symbol that I'm looking for. And now the system looked at my design, and it offered me M5 as the next motor. So simply going to type in a description here and assign the proper location for my system. So we're going to put this in the other conveyor location. And we see the electrical components. Great, so M5 is added, and we're going to connect this to our terminal strip X1. Great, that's good for now. So let's look at the power schematic. So we already have the connection for our 3 motors here. So our job is to replicate this. So obviously we can select, copy, and paste all those symbols. But for this demonstration, we're going to go through the process of building this. So first thing is to define which wires we're going to use, and simply select the start location. Great, so we have multiple functions here to manipulate the wires, and those wires are more than just lines. So let's copy this line here and paste it there, and if I paste it on this one here, it already created a connection to the other wire, and it split those lines. Let's say I bring this endpoint here along this line here, and it does the same thing. If I bring it back somewhere on the other one here, it disappears, and it fixed this line. So it's really a dedicated tool to create valid wires. I don't have to deal with a trim function and delete or fillet zeros and so on. Great, so let's insert our symbol for our motor. And I want to associate this symbol to my existing symbol that I have in my single line diagram. So simply going to reattach it to that same symbol, and it got my description. And at this point here, I'm going to add a manufactured information. So we see here that we have 4 circuits. That symbol specifies that we need 4 circuits here. So I'm going to select the proper motor. And the system always provides me the last selection that I made in that panel, so I can always go back and pick from the existing list of suppliers. So let's keep this, and we see here that we have 139 elements. So we can focus on the proper component very quickly by typing a substring of the component that we're looking for. So now we're down to 66, and that's the one I want to use. So by selecting a component, it's showing us that the circuits will be satisfied. So the symbol turned green, so that's good. And now we have the metadata information associated to the manufactured part. And we can also see this into our diagram. And if we go back to SolidWorks, we also see that M5 just showed up. And we see our description, and we have the manufactured information also. So at this point I can associate this motor to the solids that I just added. So as you can see here, we have a fully multi-user environment, and all this can be done at the same time on different computers. Good. So now we're going to continue to add the components. So I'm looking for a symbol here, but the library can have a lot of components. So I can create my own reusable palette here and even use a search to say, I'm looking for symbols that are related to 3-pole systems. So now I have my all my symbols related to that type of systems. So I can very quickly here drag and drop those components, and I'm going to associate this to my existing Q4 that I see in my diagram. Great, we have all the information about the manufacturer's part. So yes, go ahead and say copy and paste on this guy here, so a lot quicker. And I'm going to associate this to my contact K4. Great. So now what I want to do is create my terminal strip. And we see that X1 is already being used, so we have multiple terminals here. We see it here, and we also have some on the other sheet. So let's simply add components to my terminal strip and associate this to X1. So now it knows that it's going to start at 21. That's good. Let's look at our existing terminal strip here. So the system is showing us that we have multiple cables associated or connected to it. We have some wires, our wires for M5 here, and our new terminals are not, they don't have a manufactured part allocated to them yet. So let's select those and simply assign a manufactured part. And again, it offers me the last one that I picked, so that's very handy here. So I'm going to use the 201 for those 3 here, and this one I want to have a different one here with the different color in my assembly. Great. And we're now going to assign those cores, because that motor is very far in our assembly and it's going to be connected using a cable. So let's simply assign the cores, and this this cable will be connected from my main electrical panel to my L4 location. So now we see that W10, there's different color here, so it's indicating that W9 is already connected or associated. W10 is available, so we're going to use this one to associate the cores and use those cores. Great. So now the new symbols. And I want to reproduce this terminal strip in a drawing. So I'm simply going to click this button here, and the system will automatically create a drawing for my terminal strip. Imagine doing this in a conventional system with blocks and lines and move and copy. This is done automatically. Great. I now need to provide power to my PLC, but I know that I already did this kind of diagram in my previous or my other sections of my project. So I'm simply going to reuse this information using our reusable elements here. So I simply have to select the existing geometry and drag and drop into my user interface here. And the system creates reusable elements that are now available to all the users across the network that are using SolidWorks Electrical. Great. So now I'm going to simply reuse it by doing a drag and drop. So now it reused the Q11, the next number, so I'm going to associate this to my existing Q6 that we saw in our single line diagram, and also associate this to my T1 terminal, existing terminal, or transformer, sorry. Great, but now where will this power be delivered? I have no way of knowing here. I need to add the origin of this. So simply going to select my wire, and it knows all the information about this wire and only allows me to select that wire. Good, it created the connection. I'm going to do the same thing with the other wire, and that's done. Good. So now I have some go-tos here that will bring me to page 7 on row number 1. This one here is located on page 5 at row 11. So I can very easily go to the proper page where this wire is connected. And this one, 0511. So we can see here our IOs for my our PLCs, so we can go and continue to walk the design here and see all those circuits. And we see here the cross-reference of components is also maintained here on the drawing. So we can see here that K1 is using those 3 circuits, and the last one are available. And we can also see this using the symbol properties. So we see that the 4 are connected and the last one is available. So far we've concluded our design, full schematic, but we're missing something very, very important. If I go to my project and look at my report, the lengths of all the wires and cables are not calculated. I have all the information. I don't have any wire number. Oh, we can do this. So we need to obtain the length of our wires. So first let's simply go to our process and assign numbers to our wires very easily. So now we can see that the system did this automatically, and we can see our reports being updated live. So now we have all the wire numbers. Good. So let's toggle to the 3D space and go back to our enclosure. Now we see that M5 is inserted. That's good. And we can go in our location that represents the chassis here. And we have a bunch of objects already inserted. And we're going to go ahead and insert our terminal X1. I'm going to insert this as a terminal strip. And it's asking us to position the first component of that terminal strip. And now it's asking us the distance between each terminal. So we're going to accept the default 0. And it's inserting the components and creating mates between the components. That's good. We have existing components already inserted in our assembly, so let's focus on the one that need to be inserted. So we're going to insert this entire group here, and I'm going to position that transformer right in the middle and locate the first one. And as you can see here, it's using smart mates to locate the components on the rails automatically. And we're going to put here ½ an inch distance between each components. So very quickly we can see that we can build 3D layouts of electrical components without knowing a lot of things about SolidWorks. We don't need intensive knowledge of how to operate SolidWorks CAD to create the electrical components. So it's very easy. It's the ideal tool for electrical specialists to create valid 3D layout of control panels. And those components can be moved around all at the same time. That's good. We see here that we're missing a little light. If I refresh this, we can see that in our the door here, we're missing a light. So we can simply insert this one. So the system is offering us a location. So I'm simply going to hit the tab to change the orientation. And what is interesting here is that I see a smart component. Okay, so I can simply click the star, and it's asking us to select the proper face to locate that light. So I'm going to select my door right here. That's good. And what the system just did for me is automatically created the hole to locate my little light. So imagine you do this automatically here, and you don't have to figure out the physical location of the holes. We just have to locate the electrical components, and SolidWorks will do this for us. Okay, so let's route our wires. So we're going to specify 1 millimeter between each wire. I'm going to use a 3D sketch route using splines. So very quickly, SolidWorks Electrical will look at the 2D schematics. We'll look at the 3D space defined in SolidWorks Electrical 3D, and we'll look also at the connection for every component and define the 3D routes. And also, it will consider the wire ducts here and will route the wires according to this. We have a tool called segregation that can help us define where every type of wire will go in our control panel. So we can say, well, this high power wire can be excluded from that wire duct. Good, so now we see our route with all the devices. Very quickly we got a valid. So let's look at our main electrical enclosure from the front, and we can see all those wires. Okay, so now let's route the cables to our motor. So for this time I'm going to use a SolidWorks route to get a real solid, and I'm going to route the cable for this device only. So now again it's looking at the 2D schematic and the 3D space to figure out the length. And it's also using the conduit here, and it's going to follow that conduit to find its way to the control panel. Great. So now we have a nice 3D cable. How did it find its way all the way to the control panel? Well, it's very easy to define a sketch that defines the route of the wires and cables. So in advance we define with lines the path that we want our cables and wires to follow, and the system will find its way using that simple sketch. Great. And now we see our cable that splits into 4 cores. Great, let's look at our project report, and now we see that we routed 1 cable, and we have the cable length, we have the cable cores with all the numbers, and we can also get the tags, and also our bill of material. We can add to our report list. So we're going to add the wiring line type. So now we see the length of all the wires, their origin and destination. That's great. One thing that we still need to do is to produce a 2D drawing of our project. So we already have our view defined with the existing components that were added to our assembly. So let's add the sketches, because we didn't create solids for our routes. So we're simply going to show those sketch. Great. We can also create the marks for our new components. So the system adds those symbols automatically. That's great. We see our bill of material that was updated. And simply going to create a document that is added to the portfolio of our electrical project. So it's going to add the document border around it, so without having to do all this work inside SolidWorks. Great. So let's access our PDM system and log in. So we already have a folder here that is set up to receive our electrical project. To publish information to our PDM system, we simply have to go to our update PDM files and answer yes. And now the electrical is actually updating all the reports, outputting all the files, creating a folder in the vault. So we see it right here, and it's putting all the files in the vault, doing a check-in automatically. And later, if I change this project in SolidWorks Electrical and republish the files will automatically be checked out of the vault, replaced, and a new version will also be added to the vault. This means that I have a full audit trail, I have full benefit of the workflow of the published file, all this without using a complex user interface. Great. Now we have all our documents in our PDM system. Everyone can look at the 3D components, benefit from the preview. See our drawings, and we see here the terminal strip drawing. And all this with full audit trail. And we can also see our bill of materials. We can find a PDF document contains all the documents of my project. The list of documents, the bill of materials, the schematics, and so on. So this was obtained automatically by simply publishing this to SolidWorks Enterprise PDM. Thank you.